Welcome to MMT Ask the Expert. This episode brought to you by Husky. Melt to mold precision. Today, I am here with Vernon Moss, the America's Market Manager for Controllers at Husky Technologies, to answer some frequently asked questions about controllers and servo control. Hi, Vern.
Good morning. How are you?
Good. All right, let's jump right into this.
Right on.
So, servo control. Viewers want to know if they can work with any brand of motor.
Yeah, you can work with any brand of motor. There's lots of choices out there in the market. Servo is not a new technology. It's been around for a long time. So there's a ton of brands out there. The only cautionary item I would mention is sometimes servo motors only work with servo drives. A lot of the ones that come out of markets that have exclusive name brands, they only want to work with their drive brands. So you want to be cautious of that. But otherwise, most of the time, we can work with about any type of brand. We do like to use a feedback type that would be like a hyperface or some type of absolute feedback so that we have good resolution as to far as where our calibration points reside and those types of things. But in general speaking, yeah, about any brand drive we can run.
Okay. Can they buy a universal controller to work with all servo brands?
Somewhat. You can do that to a point. Certainly, it's better if you go through an opportunity for us to do some sizing so that the drives fit the motor size. For example, you don't want to have a 30 or a 60 amp drive running a 1 amp motor because it may not give you the resolution that you're looking for. So it's a little bit difficult to get when it's universal, but we work closely with our customers. So we try to find what the breadth and depth of the type of servo loads they're going to address. And we try to size the drives so that it can hit that sweet spot in the middle of there and still have enough resolution to run the low ones, as well as the really high ones that are, causing high force.
Do you have to have integrated temperature control?
You don't. No, it's not absolutely necessary. Now, Husky's got a unique position in that we do offer integrated temperature control. So you could have one computer, one MCU, as we call it, the master control unit, running the entire operation. So you've got your servo control and your hot runner control all blended into one. But you don't necessarily have to have it that way. You can do just an independent freestanding servo controller without temperature control. And then if for some reason in the process the servo control needs the input from the controller to say, yes, I'm hot, if that's an integral part, then we can receive that in as a digital input.
Okay, let's move to controllers.
Okay.
What happens if I use different controller brands in my facility? Let's go over the advantages and the disadvantages.
Yeah, so, we see a lot of this in the market space. I see over the years, I've seen customers where they've got literally a cornucopia of all the different brands. And I think what happens is, especially in terms of the controllers that we offer, which are a PC-based interface with a GUI or the human interface bit of it, there's some learning that has to go on and some familiarization that has to happen with the customer. And I think when you wind up with a lot of brands, that you lose that identity that the user wants to be able to easily get to certain settings on the controller. And I don't think all controllers are created equal. So it's really a matter of familiarity. If you think about it, I use an Apple phone. I've been an Android guy at one time. At one time, I was carrying two phones. I found it really frustrating going back and forth between those two operating systems, even though they're both fine phones. I think the same thing happens with our customer experience, where they're trying to use multiple temperature controllers that have all these different ways to get into the screens and whatnot. And so I think there's some disadvantages there. And I also firmly believe, I've got over 30 years of experience with Husky's Altanium product, and I firmly believe the product is superior. And as a result of that, I think that if your facility is filled with Altanium controllers, it's going to give you a list of feature set that you just can't get anywhere else. So I really believe strongly in the brand.
Okay. All right. How do your controllers improve startup?
So I think that I would like to answer that specifically to the latest innovation that we've added to the controller, which is our ART 2.0 enhancement to our tuning algorithm on the controller. And ART 2.0 is going to give us not only the advantage of having much finer resolution in terms of the types of things that we can control well and control them quickly, is the controller now has a couple of unique startup routines that we've built into the controller that allows the controller to bring the mold up to temperature much faster than anything that we've produced in my time in the industry, as well as I believe it's probably faster than anything out there in terms of being able to go from an ambient condition to bring that mold up to ready condition very, very quickly. And that would be our stake in the ground that says, look, Mr. Customer, we believe you can save money. You can actually produce more parts if you bring that mold more quickly to temperature, reach a stabilization time more quickly, and be able to make that mold available to you to mold plastic parts much sooner.
True. All right. Is there any possibility to anticipate leakage using controllers?
There is certainly the controller, and I've seen it over the years, just standing next to presses. And when a leak occurs, you can see the temperatures rise in the thermocouples. You can see the power change on the controller. So the controller knows that. It's just a matter of taking that data into the controller. We do that through a process that we call power deviation. And what it does is it monitors the amount of power that's going out to all the individual zones, specifically the tips, I think, where leaks most time happen. Mm-hmm. And then it compares those to the group and makes sure that everybody's on an even playing field so that, there's no outliers. And then it looks for that outlier. So if for some opportunity happens where there's plastic that encapsulates the nozzle, it would affect the amount of power being drawn by that zone. We can flag that and say, hey, there's a possible leak that's going on in the system. There are some other benefits to that same technology, though. It can also detect things like a water leak that would happen down in the pocket. So if that water leak occurs, it can change the amount of energy that's being drawn by a tip in this example. Then you can flag that as well and say, hey, I've got a power deviation situation happening on this particular zone. And as a result of that, you now have a choice to make as a molder. Do I stop and examine this problem, or do I go ahead and run production? Unfortunately, the guy making that decision is rarely the guy that has to dig the plastic out of the pocket after the leak happens. So sometimes they decide to move on anyway. But you do now have the opportunity to know that something's happening and be able to go in and make a plan for when I'm going to change that situation and make it better.
All right. Does the controller remember the tuning, or does it retune every time the mold is started?
We remember the tuning. In our situation, we have a unique position where we have many hundred, maybe thousands of mold setups that can be stored inside of our system. It's got a very large capacity for storing individual mold setups. And as a result of that mold setup contains that information, what we call the ART information, which is the tuning information from the ART 2.0 process that happens in the tuning. So there's really no need to go back through that process a second time. In fact, it's probably not the best idea to keep going through it. You want the results to be consistent, especially in the world of like medical molding, for example, where really a validated process is what you're looking for, and you want to be able to follow that process throughout without having a lot of variation that pops up.
Exactly, consistency. So does the system tune continuously even while it's running production?
It doesn't. In fact, we would probably consider that to be a pretty bad idea for the same reason that I mentioned before. If you're continuously tuning, the user doesn't really know that, so they're not aware of it. So you could introduce some type of variation into a stable process. And that would be, catastrophic for, again, if I go back to medical example, I need those parts to be made consistently with a validated process. And if I'm tuning all the time or doing some kind of continuous tuning in the background, we can create a situation where things could walk away from your validated process. And, with nobody standing by and monitoring that all the time, because there's less people on the plant floor these days, then you could potentially make some really bad parts. So, we believe that it's best to be done, one time at the beginning of your process, validate the process, and then let the controller do its job throughout. And it should maintain. There's really no reason it should be walking away from the set point or having difficulty with tuning.
All right. Is it worth upgrading my old controller to get faster heat up times?
Probably. If you think about it, that faster heat up time is giving you more production. And at the end of the day, that's what everybody's looking for, right? I think most molders want to be molders. They don't want to be electronics experts. They'll leave that to the experts. That's what we do. And to make more molded parts is the goal at the end of the day. So if the ART 2.0 process tuning and some of our tuning, our heat up strategies can give you that mold available sooner, you're making money. So at the end of the day, you can do a return on investment and look back at that and say, is it worth it or not? I think there's diminishing returns for old equipment. They're electronics, so I don't know if there's much appreciation in our market space for understanding that it's not that they wear out, it's just that the technology becomes outmoded. And at some point, from a maintenance standpoint, they're causing you more maintenance time than you're getting uptime out of them. So it's time to move on. And certainly, most of the time, I mean, I see literally the first controllers I ever sold in the industry are still out there running. Which one of the reasons I believe in the product the way I do. I mean, they're workhorse product. However, everything reaches its end of life at some point, so it's time to move on. And I think the new technology available can put money back in the molder's pocket.
Excellent. All right. How can I keep from shooting into a cold mold or flashing the mold?
So it's a pretty simple answer, really. Is you got to tie it into the molding machine operation, so that when the controller does detect a problem or the controller is not running, it can tell the machine, "Hey, pause, stop." It's really easy to set up. It's remarkably simple. It really just contact closure coming off the controller. We have a signal inside the controller that says "at temperature," which is telling the controller all time that all zones, because we're an integrated controller, we can take any number of zones, aggregate that into one signal, and then say that signal is telling the machine that it's okay to run. So I have an at temperature signal, and that at temperature signal then can be tied into the molding machine. The molding machine, either through logic or through some simple wiring, can be instructed to stop or not inject whenever that at temperature signal is there. And that can be a big dollar savings. We've had customers that don't have hookups to them, and they wind up, like you say, flashing a mold. And it takes time to put that mold back in production again. It's a lot of loss in production. And I would hazard a guess that to hook up the simple IO required to do that is certainly less than $1,000, and that money is saved back many times over. The first time that machine stops because the temperature controller has either not been turned on or something's happened, blew fuses, whatever it is, and stop the operation.
All right. If electrical leakage stops the controller, can I run the controller anyway?
You can. I guess the better question might be: is it a good idea? So, I've got a heater, and it's a what we call electrical leaking. So it's actually draining off some of that electricity is going down to ground, hopefully, not going someplace else that might be problematic. But yeah, you've got a heater. The heater is not necessarily perfectly insulated, so you've got some leakage voltage that's now going off the ground. Our controller can tolerate an insane amount of power coming back to it. We use isolated thermocouple inputs, which is the main point for leaky heaters to cause a problem with the controller. So there's really no upper limit for what we have to set for how much leakage it can take. Our controller, we decided 0.5 amp or would be the right amount of power to now flag and say you can't run anymore. But of course, you can go into the background, turn that value up if you wanted to. I think the main point is it's a very sophisticated piece of electronics. It can detect when that is happening, and then you can make that decision on your own. It's not going to hold yourself to the fire. Literally, was it Monday before last? I was at a customer, and they had a situation with this big manifold heater, and it was causing a lot of leakage output, and you could see it right on the screen. And the customer, I was like, "Well, why don't you fix it?" And they were like, "Well, it hasn't quit yet." It's like, well, it's gonna, right? It's leaking, it's going bad. So if nothing else, Mr. Customer, I'm giving you the ability to see it. Go get the spare parts, have them available. So when it does fail, because you'll be able to get back in process quickly. So it's one of the things the controller can tell you about. It doesn't necessarily have to shut you down unless it would be a severe leak, but it certainly gives you the ability to be proactive and set yourself in a position where you can get back in process quickly.
And that's the key. All right. Last but not least, can plastic leak detection detect other faults like water in the bore?
Yeah, and I kind of alluded to that earlier. So it can detect leak. So here's the thing about this plastic leak detection thing that kind of gets me a little bit. Unless you've got a device down in the mold that is detecting the presence of plastic, it's really hard to call this plastic leak detection, right? So instead, what we're doing is we're using the electrical outputs that we read off the thermocouples and off the heaters to make decisions whether or not that is a leak or not. But as a result of that, other things can cause that same thing to trigger. Water leaks would be one of those things. I've seen, pretty oddball things where a zone may be getting too much cooling water. They've changed the cooling water temperature arbitrarily during the process, and you can trigger those alarms, from those types of things. So there's other things that can cause that to happen. I guess what's important to know is that the controller can say, look, something's changed. Somebody needs to address this. We do not shut the mold down because we see a leak, a plastic leak. Or power deviation. It's a warning. We set the alarm off. We let the user come over there and then make a decision on his own as to whether or not he should shut that down or not. It's not something that's going to be a catastrophic failure. Not that we couldn't build that into the system. It'd be fairly simple and easy, but we don't want to make that decision for the molder because as I said before, I think a lot of times the guy who's making if he's still making good parts, he's probably going to run.
Exactly. I mean, the end result is you're giving them information, you're giving them data to make better decisions to stay in production.
Exactly.
All right. All right. Well, thank you, Vern. Thank you for your time and for your insight. To those watching, be sure to check out the 3 other installments of this special 4-part series on Heartrunner technology, brought to you by Husky Technologies right here on moldmakingtechnology.com.